Welcome to my channel. Your tutor Mariam is here. It's a 26th video of Introductory Physics 1, and the 7th video I'm going to talk about the motion in 2 and 3 dimensions. In the last videos I talked about the projectile motion and equation of motion, and I solved a couple of examples. But in this video and the next videos I'm going to solve more examples. And in this example, you can see how to choose the equation of motion based on the problems you have. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. In this problem, a shell shot into the air during the firework with the initial speed of 20 and angle of 30 above the horizontal. As it reaches to its highest point, it ignites. So calculate the height the shell explodes, how much time it takes, and what is the horizontal displacement of the shell when it explodes. Let's see what values I have in this problem. My initial velocity is 20, and then it makes the angle with theta is equal to 30. It's reached to its highest points. That means the second velocity gonna be 0, and then it wants me to calculate the height the shell explodes. So I need to find y here, right? That's the value I'm looking for. So my angle here, theta, gonna be 30 degree. At the highest point right here, my velocity v1 gonna be 0. And then my initial velocity v0 gonna be 20 meters per second. At this point, the best equation I can choose is this equation. So h equal to v squared sine squared theta 2 times g. The reason I'm saying this is the best equation I can use, because problem says it's reached to its highest point, right? And I do have an equation for that. So I'm not going to use the other equation to find the other values like time and then substitute this value to the other equation to find the height, because in this problem I have velocity, theta, and I'm looking for h. So this is the best equation I can choose. Now let's substitute the value for v. I have 20. It's going to be a square. Sine, my theta is 30. A square. 2 times g is equal to 9.8. And then it's going to be 400 times half a square, 19.6, equal to 5.1 meter. Now let's look at the second part. Here I need to calculate time. Let's see what equation I can use. So my first option can be this equation. Y equal to half of g t squared plus v sine theta t plus y naught, right? This is gonna be my first option. My second option can be v equal to minus gt plus v sine theta v naught, and this is gonna be minus. I can use both of these equations. In the first equation, I have height from the previous part. I know g is equal to 9.8. I'm looking for t, and then I know what is the initial velocity. I know angle, and I'm looking for time, right? My second option also have velocity, acceleration. I'm looking for time, and I do have the initial velocity, right? So you can use both equations, and they both should give you the same answer. But in your exam, in your homework, you also want to save time, right? If I go with option 1, at the end, if I want to calculate t, I have t squared plus t, right? It's going to be some values, t squared plus some values, t, right? So you might find it difficult to find t with equation 1. However, if you go with equation 2, there is only one t here, and it makes calculation a lot easier. So I like to choose equation 2. Now let's substitute the value. My v here gonna be 0 because it says it's reached to its highest point. So this v gonna be 0. And then my g is equal to 9.8. I'm looking for t, plus my v gonna be 20, and then sine 30. Then 0 equal to minus 9.8 t plus 20 times half, then is equal to minus 9.8 t plus 10, and then minus 10 equal to minus 9.8 t, and then t equal to 10 divided by 9.8, and that's equal to 1.02 seconds. And that's gonna be my final answer. Now let's look at the last part. Here, I need to find the horizontal displacement of shell when it explodes, right? So literally, I'm looking for this distance right here, x. So my first option can be x equal to v cosine theta times t plus x naught. And then my second option can be r equal to v square sine 2 theta over g. So my question from you is, can I use equation 2? Is it possible to use equation 2 for this problem? You might say there is no problem to use that equation because I have my initial velocity, I have theta, and I have acceleration, so I can easily find r, right? But let me remind you what is r. R is the maximum horizontal displacement. So at this point, for r, if you have the particle starting at this point, going up, and then come back to the same position it was, then this displacement gonna be r. So it's going to be your maximum horizontal displacement. However, in this problem, it's not reached to its maximum. It ignites at the highest point. So that's a difference between these two problems. So you cannot use equation 2. Because if you calculate r, technically speaking, you calculate the maximum horizontal displacement, and this is not what you're supposed to solve. Another things, you might say, okay, I'll calculate r, and then I divide it by 2, right? So it's gonna be half of this distance, so it's gonna be the same as the answer I'm looking for, because it looks like this ignite at a half of the displacement. But my question from you is, how do you know it reached to the half of the maximum of the horizontal displacement? If you look at your problem, it doesn't mention that. So you can't assume it's reached to half of the maximum displacement. You have to see some hints in the problem, then you can solve it based on that. Otherwise, you can't assume anything while you are solving the problems. Now let's substitute the value here. My v is 20. It's gonna be cosine 30 times, I found the time in the previous part, it was 1.2, and it's equal to 17.3 meters. And that's gonna be my final answer. I hope you find the part 1 of solving the problems about the projectile motion helpful. If you like my video, hit the like button, and I'll see you in the next video.